All right, so we're on acceleration homework 1, number 3.
It's just going up and down.
Are we doing it?
Okay. So in this one, what it's showing you is that you have your car, it's at the bottom of the ramp. When you start looking at it, it's already moving, someone pushed it. And our idea is that it's going to go up to the top and then come back down to the bottom. Is that cool? So this is what we're talking about here. So if you can see me. Okay, we're looking at this. So someone gives it a push. When we're going to start looking at it right after I let it go. And then we stop looking at it right before I catch it. Does that make some sense to you? Okay. I'm going to do the graphs up and down because it's just easier for me to draw. They're left and right on your board, or on your. All right. If you would, check with your neighbor. See what you think this graph should look like. All right. Remember, the far left side. The far left side of the ramp is 0 position. The far left side of the ramp is 0 position.
No.
The far left.
The far left side of the ramp is 0.
It's going backwards, so it's negative. So it's going like that.
So wouldn't it be kind of like, does it go up first?
So that's going back in time. So time went forward.
Yeah, you're right.
So.
Acceleration.
Oh, okay. Except remember.
Yeah, no.
It's like not existing.
Like a scrap, right?
No, it was just hard. It was like slowing down. It's like slowing down and
You said the far left side.
and then it speeds back up.
Oh.
And you push it and it goes slower. And then like it slows down as it's going up because it's going up.
What he
And
did,
then
when the
that's
velocity
what-
goes-
Yeah, so
the
you
far
go
left side is
slower
zero.
and then it goes.
So they're doing weird though.
But I think that maybe it's.
Remember, the steepness tells you.
Yeah.
These are standard.
Well, maybe it's
Shell.
Because this is
Okay, so you have yours.
It goes faster.
0 is here.
Oh, it should be opposite. Wait a minute.
Here starts
Would it
marking.
be like?
No, it starts at 0.
Bang.
The 0 is the far left side of the ramp.
It would be like this. Look at this perfectly.
I think yours is upside down. Oh,
So it's actually like the
Yeah.
route.
This shows you at the 0 and ends at 0. So yours starts marking the 0.
Negative because it's moving to the left.
So bad.
I don't like this. At all.
So good.
What do you mean? So good. That doesn't help me.
So good.
Doesn't help me.
Let's go. Me and Max did the same thing.
Well, that's not nowhere then.
Yeah.
Probably not this one. What is that? That's a text. No, because I was trying to. I don't know, but like. This one is so good. I was like, that's a text for this thing.
All right. Let's provide a little context. Okay. Let's provide a little context. One thing that the overall directions say is that the left side of the ramp is position 0. So if I put a star here, for example, and a, what do you want to put, a hexagon?
Or a square.
Okay. Where are those on our position axis? Well, the star is at the 0, so the star is here. And where's the hexagon?
At the top of the X.
Right? Is that cool? So where's the car start?
At the top.
At the hexagon. And then where's it end?
At the hexagon.
And what shape does it have to have?
Parabola.
Starts with a P, ends in parabola. Good, parabola, excellent, right? Now, it's fast when you first start looking at it, so it's steep, slows down, and then speeds up again. So we're going from steep to shallow to steep again.
Whoa. It's like raining.
Why isn't it just,
Well, so it could, if I push it all the way up here,
Excuse me?
right?
oh, well, you did.
Oh, you had them.
So basically, well, Paul says, like, well, what are you talking about here? Like, where, how high did it get here? So maybe it only got to here.
Well, I haven't addressed it.
I'm starting right now. I feel like my stomach is-
I had it increasing.
Oh, so good.
Yeah.
All right, you guys good with this? So far, so good? All right, now,
Because it starts
what about the velocity? What direction is the velocity when we start?
Negative.
It's left, correct? So if you look here, the velocity is to the left, correct? So therefore, the velocity is negative. Does that make sense? And then when it gets back down to the bottom, so it goes up and then comes back down, when it gets back down to the bottom, what's probably true about the velocity? It's positive, right? So we know it has to start negative and end positive. All right, let's see what you got on that one. Oh, as a general sense, when we start looking at it, is it already moving?
Yeah.
Yes, so think about this. We start looking at it after I let it go. So,
If I didn't fall up there, it would have fallen up the end.
okay? Is it moving when I let it go? Yes, it is. So, can the initial velocity be 0? No. So, if you have this point here, 0, 0, you may need to rethink it. Okay? See what your neighbor thinks.
Because it complicates it.
So,
It's so fucking. I had it as like a.
Oh, yeah.
This is the dumbest thing.
Well, it's a straight line.
And then I just went on.
Well, it's Mr. Drew.
It was hard.
Oh, I think it's way too big and I was like.
It's a lot of boys. Fresh little girls.
That's saying it's negative.
I think you're on the wrong there. It's not there yet.
That's the exciting.
No, I'm giving up. I'm giving up. I just like accepted that I didn't see that. If I do it, it's gonna.
So this is starting with the negative velocity. All right. You ready? So let's say that it starts off with some, it's moving left when we look at it, true?
Yeah.
So at time 0 it has some large negative velocity. Is that cool? What happens to it as it goes up the ramp? Does it slow down?
Yes.
Yes.
It has to, right? So this line here, if you're going toward this line, you mean you're slowing down.
Or this way. Sorry, okay.
How's that look?
Speed is always.
Yeah, that's good. How's that look? Is that cool?
Yeah.
Now, we're going to explore this a little further. I'm just, yeah.
What about when it like slows down? I thought you said they're not.
I know, right? That's a great question. No. What about when it slows down to hard? All right, now, what about the acceleration graph? What about the acceleration graph? I mean, what's our definition for acceleration?
The slope of the velocity. And
Yeah, he said velocity over time, he said slope of the velocity graph, is that true?
Change of velocity.
Okay, but I don't know, like, a couple people have this on their page.
What's the slope of this line? So it's always positive. Because this is a positive slope.
You like this or no?
No.
Check with your neighbor, decide whether you like this or not.
Yeah, this is
Okay? Do you like this or not? Does this make sense to you? It makes a ton of sense to me. Yeah, because for the first half it says it's negative acceleration, slowing down. Right?
Okay, so you're saying,
Well, that's wrong. That's
it's constant.
Is it?
I don't know what's happening.
it's only one slope.
No, because
Okay,
if it
what's our
starts at
definition of
negative,
this?
then the time that's negative velocity.
It's getting less negative.
It's getting less negative.
It's like,
He's also put
Yeah, it's getting closer.
yeah, that's a problem.
All right,
I agree wrong.
so we're having a little bit of a cognitive dissonance here,
Oh, I learned that.
but that's good
It's not the
because if you have cognitive dissonance, that means you're ready to learn something. I will tell you why this makes sense to me, and you can tell me what you think about that. This has negative acceleration and positive acceleration because for the first half it's slowing down and the second half it's speeding up.
Yes.
You with me on that?
No,
That's what,
I mean, yes, I'm with him, that's sorry.
that's fine. That's why I like this.
That's right.
No.
No.
Oh,
It is.
God.
Go ahead, Matt.
So, for clarification, the slope, the y position of the acceleration is the slope of the velocity, right?
Yes, the value of the acceleration is the slope of the velocity graph.
Right, so the acceleration, so in order for the slope of the velocity to always be positive, the acceleration also has to be positive all the time, which in that graph it's not.
So he says, if you look at this graph here, two things about the slope of this green line. What's one of them?
Positive.
It's positive, what's the other one?
Constant.
It's constant. So according to that then, you're saying that that's what we're looking at.
Yes.
Well, let's see if this makes sense with our other understanding. If I just put the car on this ramp all by itself, where would it go?
Down.
Would it go down and to the right?
Yes.
Therefore, the acceleration is down and to the right, and the right direction is positive. Does that give us a constant positive acceleration?
Could you say that one more time?
Yeah. Because the ramp is slanted down and to the right, a car put on the ramp would go to the right. Therefore, its acceleration is to the right, and right is positive direction. Now, remember,
Unaccelerated.
this is our first experience looking at this. it's not going to be crystal clear to you when we're done. We're going to have to do a lot more practice so that it kind of solidifies in your brain and all this other stuff. So if it's not crystal clear, it's cool. Okay.
Wait, so how do you account for the positive and negative acceleration on the?
So that is a great question. He says, it's still slowed down and sped up. True. But how does this graph show that it's slowing down and speeding up if your acceleration is positive the whole time? Do you understand that question? That's a genius question on a Monday morning. Okay? We're going to have to see some competing ideas here. Okay? If you flip back to page 1 for a second, if you look at the top one on page 1, the acceleration was positive and your car was speeding up the whole time. True? But if you look at the second one on page 1, number 2, your acceleration is negative, but your car was speeding up the whole time.
Yeah.
So I don't think, just given our couple examples, that just looking at the acceleration tells you whether you're speeding up or slowing down. I think it's a little bit more complicated. But we're gonna have to find it. Like, it's gonna have to come out. Yes?
So, what about the second, though, or that however much time it is at the top of the ramp, when it slows down, stops momentarily, and then continues back down?
Stops momentarily? That's what you said, right?
In theory, it stops momentarily. It probably doesn't. But
Stops momentarily?
Technically, it never stops.
It doesn't.
It doesn't stop. It does stop.
It does?
Which is it?
No, it doesn't.
It does or it doesn't?
Because it immediately starts going the other direction. It does stop. Wait.
It does stop.
The wheels.
Okay, let's check it. Let's check it. Are you ready?
right there. At the top.
It's so small that you can't see it, but it immediately starts going the other direction.
It doesn't stop.
It just hits it. and
No,
then-
it pauses, but it doesn't stop.
All right, so let's check with your neighbor.
No, because
See what
it's
your neighbor
switching
thinks.
directions.
Does it stop? Does it not stop?
Wait, Mr.
Do we have any evidence of these things?
What was that one?
That was in theory.
Instant?
As you're moving, it's so slow.
I went on Belraven on Saturday night.
I'm sorry, you did what?
I went to Cedar Point, it's on Belraven, and it stops at a nice rate. It's not completely stopped, it just, it's not moving fast.
No, it does stop. Belraven stops.
Whatever, it's like, it just moves slowly down, then it.
That sounds horrible.
It was fun. My hotel room got on fire.
We know.
It was great.
Not her. The story keeps changing each time.
No, well, not my hotel, my hotel. The room below me got on fire. Because they were.
What are we thinking? Stop or not stop? Stop? All right, so let's entertain all the comments. I would like if you could argue for some evidence, please. That would make this a little bit easier. I want to hear here, and then we're going to go here.
I argue that it stops because it crosses 0 in the velocity time graph. Or the velocity graph, I should say.
It's the velocity time graph.
Yeah.
So your evidence says that if you look at the velocity time graph, I don't know which one it is. It's one of these.
Where do you put these videos?
Your evidence is that if you look at the velocity time graph, at some point, it literally, the green line crosses the t-axis. All right.
I was going to say the same thing.
You were going to say the same thing.
I have a DVD.
You what?
I want to argue that it doesn't.
Okay, give it to us.
So I don't think it stops. I think it just changes directions and it like starts rolling down, but like it's extremely slow, but then it goes down.
Okay.
Yeah, that's a stop.
Right there.
Does it change direction?
Yes.
It does. In fact, what I like about that, okay, what I like about that a lot is that if you look at the velocity time graph now, given that context, I think something really interesting is true because what are the values of the velocity before it gets to that place? They're negative, correct? And then after, what do you notice about the values?
Positive.
This means it's moving left, this means it's moving right. Correct? So I'm okay with that. But Bella, what do you say to their argument there that if you look at this moment in time, what is the value at that instant?
I did not think that far ahead.
That's okay. Go ahead, Grace.
It has to stop because it can't change directions without coming to a stop.
Is that true?
Yes.
Okay, go ahead, Kyle.
Yeah,
It'd be like, it's like a super little stop, like that we can't like exactly see it. So like if we had like a super slow motion camera, we would be able to see that it would stop at some point and then go backwards.
Okay. How long does it stop for? That's right. We have a term for this, right? What is our term for the smallest amount of time we can conceptualize? The instant. Does it stop for an instant?
Yeah.
It totally does. Okay? You guys okay with that? All right. Has to switch direction. Now, here's the real question. You guys ready for the real question? I'm gonna push this. I'm gonna push this up again.
but the acceleration graph doesn't look
Oh, no.
And so what I'm going to do here is I'm very good at releasing it from one place and then catching it at the same place. I would like you to answer this question. Do you think it spends more time on the way up or more time on the way down? All right, so check with your neighbor on this one. More time on the way up, or more time on the way down? Check your neighbor, yeah.
It has to start from the base, like almost.
But yeah, that, I'll have it before,
I think it's.
All right, so we're gonna vote. We're gonna make this multiple choice. A, more time on the way up, and B, more time on the way down. Who says A, more time on the way up? B, more time on the way down.
Well, we will.
There's a lot of people that may have been confused about the choices. A is going to be more time up on the way up. B, more time on the way down. Ready? More time on the way up. B, more time on the way down. There's still some people that didn't vote.
The same.
Because there's like the same amount of.
In theory, it should be the same.
Oh, you said secret answer C?
Yeah.
Same time up and down?
C's. Secret answer C.
That's a trick answer.
We say C.
Well, I didn't know there was going to be a secret answer C.
Always a secret answer C.
Always a secret answer.
That's why I would not go with C.
Always the third option.
All right, Xander, what do you think?
I think it would be B because in like a perfect world with no friction, I think they would be the same, but because it seems like it should be the same with the initial speed being okay.
I like Xander goes, okay, B, but really C is what I'm trying to say.
They should be.